Thank you very much, Dr. Marwan, for your introduction. Okay, thank you also for your presence for that particular panel discussion, which I think you will find our exchange of ideas interesting. And for the young engineers who are in the audience, I think you will find some useful, how can I say, directions which comes from our experience. You see the title. The title is a little bit, I think we tried very hard with the organizers to make the title, how can I say, important for you to follow the panel discussion. So we're talking about the future of the tunneling, because all of us here in the podium, we are tunnel engineers. We have experiences more than 25, 30 years, each one of us. And we would like to start the discussion by asking, or if you like, by trying to say something very important. What is the tendency for the new tunnels, Are we going for large sections? What is next? And these are the main topics which I would like to share with the friends for the podium. You see the two main topics is how do we balance the integration benefits of large tunnels against the increased excavation volume, lining demands and temporary works risk, and are large tunnel sections genuinely improving resilience and whole life performance? That, as I told you, the tendency now is going to larger tunnel sections. And these are the main topics which I put as questions to the audience, and I would like to ask Dr. Ahmed to say his opinion, having the experience working with RTA for many, many years now. Okay.
Assalamu alaikum. Thank you, Doctor, for your introduction. Okay, and for sure I'm happy to be with you today. The topic which you raised today is very, very interesting. Especially the trend now in Dubai is to convert all the utilities to tunneling. Okay, and even if you see later the announcement of Sheikh Mohammed bin Rashid for Gold Line, it was all the line, almost all the line is underground tunnel. But when we speak about large tunnels, it's something different, because large tunnels may have an integration with a multi-mode transportation like roads or metro, in addition to other utilities from other authorities like DEWA or Dubai Municipality. So the challenge here is become more difficult. Okay, you have to combine all the authorities in one corridor, in one location. So you have to calculate for the whole lifetime benefits for all authorities. It's not only one authority that will utilize this. So you have challenges in maintenance, you have challenges in operation. All of this has to be collaborate together in order to deliver a safe operation and safe working condition. Okay, for sure it will maybe in the long term it will benefit for the city, because the tunnel itself will decrease the surface area. The intrusion of the structure in the surface. Okay, and also you will have one access for maintenance, non-disruption in maintenance itself. So there is a lot of benefits, but at least we have, in order to take a decision to go for long or for large tunnel, I believe we should have like a big or a complicated risk management model, like with Monte Carlo model or any other technique. Okay, in order to evaluate what is the benefit from considering the construction cost in the beginning, high construction cost, against the long-term benefits.
So, Dr. Magazi, your experience is very long, and working with so many companies, especially Systra, what do you think about the tendency now? We're talking about large sections versus the smaller or the ordinary ones. And allow me to say, when I speak about large sections, we speak about diameters of more than 10 meters. This is at least my appreciation of large size tunnels. Please.
Sorry. Good afternoon, everybody. Actually, it is a very interesting question because all the time it comes into the question in front of the authorities, and it depends on many factors. I just wanted to mention here that recently I found that the working group number 20 from International Tunnel Association have issued a guideline, general guideline, for the choice between twins bore tunnel or single bore tunnel, in a way to identify the many factors can affect the choice. And this guideline, actually, it is published recently, and I emphasize, I recommended all my colleagues to review it. I return to the question raised by my colleague, Mr. Elias. Actually, we have to identify between the function of the tunnel. It is railway or transit, or it is road. It is an urban, or it is outside the city. And sometimes, in some projects, the client wants to reuse the same machine, the same TPM machine, and this has happened in one of the projects in Egypt, that after the machine with 9.5 diameter have been used for line 2 of the Cairo Metro, they use it as a road tunnel, but in this case, actually, they make 2 tunnels, not only 1. So, in general, many factors, according to the guideline, affected the decision. It is length of the tunnel, diameter of the tunnel, urbanism, impact on the environment, and of course, the cost, construction logistic, delay of the project. All these factors can have a significant impact of the decision. But at the end of the day, also, there is limitation for the tunnel of 10-meter diameter, especially in the city, concerning geotechnical constraint, especially also if we have a minimum, we have to, let us say, respect more or less rule of thumb for minimum overburden, and this will have an impact about what is geological condition we have. And most of the cases, especially in Dubai, we have a mixed ground, and this will become one of the challenges. So the topic is very wide, but by more or less make some factor divided the decision in some level of factor or weight to give a good way to have a decision, I think it must be done. So I cannot say it's a general, let us go for this or that. We have a certain criteria, a matrix or whatever, it has to be studied. This is my background for this one.
Well, thank you very much, Dr. Mohammed. Dr. Psomas, Sotiris, can you?
Good afternoon. I think you gave me a doctorate.
I gave you a doctorate. Yes, it's an honor, yeah.
Right. I think the answer lies in the question itself, is how we do balance. There is no right or wrong answer. I believe depends on the situation, the type of the project. And for us, who have a strong geotechnical background, obviously the ground risk is of high importance. So, but looking overall, and through the design and service life of the structure, there might be benefits, for example, for larger tunnels, which will require planning and obviously buy-in by ultimately the client, the employer. So it depends on the occasion. A simple example is the large-size TBMs around the world. This seems a solution that has been preferred by a number of clients and employers, but this doesn't mean that they are not coming with their own risks and require a significant planning.
Let's proceed to the next, Raj.
Yeah.
Please.
Good afternoon, everyone. I think there are two questions here. One is, how do we balance the integration's benefits of large tunnels against the increased excavation volume, lining demand, and temporary work risks? Other one are large tunnel sections genuinely improving resilience and whole life performance. So I think most of our panel members already described that the first questions. So there's a mixed view. So we need to look at it in a whole life cycle. So in my view, if you answer the second questions, then they can do both. And that what makes such an interesting, I think that's what we are discussing here. Traditionally, resilience was often viewed as an asset level. If we made an asset stronger, larger, and structurally strong, then we considered it's a resilience asset. But increasingly, we are realizing that resilience has to be evaluated the network level. If the network is, we need to accommodate everything within the single tunnel, we need to look at it in a network level. So larger tunnel obviously can play a pivotal role to accommodate all the different networks within a single bore. Then it will offer greater operational flexibility and maintenance. It also enables accommodation of future capacity of the future demand. So today, we may not predict what is actually required in a 50 years' time. So when you take about the Dubai, so finding the land or corridor to construct the large tunnel or tunnel is even very difficult. So if you consider that future proving within now, then accommodate that one, then it will add more value. So, but there's another side of the equations. We can consolidate multiple assets within a single tunnel, but at the same time, we are consolidating the risk as well. So if one of the system fails, then we need to cut off that tunnel. It will take time to repair and connect all other networks into the operations. So we need to consider that aspect as well. So one thing our industry is getting better, it is distinguishing between structural resilience and system resilience. Tunnel may be structurally extremely robust, but if the surrounding network depends entirely on that tunnel, then the system vulnerability still exists. So this is where the digital monitoring, predictive maintenance, and operational planning become increasingly important. So resilience is no longer just about the concrete lining or ground support system. So it's also about how effectively manage the asset throughout the life. So looking ahead, I believe resilience assessment need to become more multidisciplinary. We need to bring engineers, operators, and all the planners and asset owners. They need everyone involved in the early stages of the design. So ultimately, larger tunnels can absolutely improve whole life performance, but only when they are supported by appropriate operational strategies and network level resilience planning. Otherwise, we risk creating highly efficient assets that become critical single point of failure.
Okay, thank you very much for that. So just to summarize, according to Dr. Mohamed Maghazi, there is not a real direction to go towards large size. We have to think as engineers the risks and identify the real problems before we make one or the other solution. According to Raj, the idea of using large size tunnels is here, and we shall see more and more in front of us as ideas and as projects. Just to mention a couple projects which I have in my mind, Smart Tunnel in Kuala Lumpur. It's a very large size of a tunnel which has multi-purposes, storm water and motorway at the same time. And there is also another, most probably Mohammed knows that, it's the peripheral tunnel of Paris, which is a double-deck tunnel, motorway. One, the upper goes towards the other direction, the lower goes to the other direction. Works perfectly, but it's a decision which will come, which has to be taken by tunnelers more and more in the future. So let's proceed to the next issue, which I would like to raise as a topic which I prefer to discuss now. Let's go to the tunnel final linings, the final product, which is the concrete linings. And of course, there is the need to increase durability and reduce the carbon footprint. And I would like to ask two questions. How can we reduce the carbon footprint of tunnel linings without compromising long-term durability and service life? And where do we see the largest opportunity for improvement? It's lower carbon binders, reinforcement innovation, lining optimization, or changes in construction technology. Just to mention that there is a lot of progress in using new reinforcement, like for instance steel fibers, polypropylene fibers now. More and more comes to the design as things which needs to be treated. So I would like to ask Dr. Ahmed his opinion on that, because he's coming from RTA, so he can provide us the idea of the client in this type of issues.
Well, I think for the carbon footprint for any project, not only for tunnel, it depends in main items. Yani, first of all, optimization of design, concrete thickness. Okay, this I think this one of the major points that we have to look at when we speak about carbon emission. Also, it can be also reduced by using recycled aggregate or recycled material in steel fabrication. Okay, it's not also, I believe it's not the main point that for large tunnel, this is a common exercise for all. But for large tunnel, it can, this can be, it can be done through reducing logistics, or using innovative technologies, okay, in tunneling, which reduce logistics and to reduce the carbon emission due to the site logistics and this. Okay, yeah. Dr. Mohammed?
Thank you for this question. I think since a few years we started to hear about the carbon footprint and all the trial to reduce the carbon footprint of the tunnel line. There is two aspects on this one. Of course, there is the material, mean that the material of the lining, reinforced concrete, now using the fiber instead of classic reinforcement has become something normal, and it enhances in many aspects to reduce the carbon footprint from using confidential or classic reinforcement. Of course, it depends on the situation. The second item is related to the concrete. And if Mr. Elias allow me, I mention an example that one of the contractor in project of Grand Metro Paris succeeded to change the type of cement with the approval of the client, and this kind of cement also have a good impact to reduce the carbon footprint. So can we, the fiber, people are similar, there is code, there is everything. Mr. Styros can give a very good insight about that. But are we capable also to propose a kind of material for the concrete, which is allowed to reduce the carbon footprint, and the client will approve? The example I gave, it is the contractor proposed, the client approved, and they applied. So they succeeded for, I don't remember the percentage exactly they calculated, for reduces the carbon footprint. So yes, the question, we can reduce by good willing for both parties, the contractor and the authority or the client, but in a way to be also satisfied the durability. This is one of the major factor for the design. So applicability of this, it is a way. Second point, just very quickly, I don't want to take more time, the dimension of the structure. And I think there is a very good, interesting discussion this morning concerning, started by have a good understanding of the geotechnical parameter, the ground model, and the input for the design. And also, when we have understanding the ground model, of course, we will make most proper ground model in the calculation, and will reduce also the conservative approach in the design. It will reduce the dimension of the concrete, and I think I'm sure that it will reduce also another source to reduce the carbon footprint. Thank you.
So I know that you have worked a lot in steel fibers reinforcement for final linings. And please feel free to go through to this slide, explain a little bit about the fact that we are here now to discuss also value engineering by using the steel fibers as reinforcing elements of the concrete linings.
Thank you. So what was mentioned is true by Dr. Magazi, but the steel fiber reinforced concrete is in use for more than 30 years in Europe. So going back, please. This has been implemented successfully in many projects, especially for primary lining, because it brings about a number of benefits. One of them is durability. At the same time, binders have been used in concrete, reducing the CO2 emissions. For secondary linings, there was some resistance. What you see on screen now is something that has been built perhaps now 10 years ago, but the design has been replicated in a number of projects around the world. So about 12 years ago, we embarked to remove the rebar completely from a secondary lining. That was a pressurized tunnel, a Schwetz tunnel. And in order to achieve that, we need to have to provide confidence to the client that we won't have a failure of the lining, but we will have controlled cracking. So this is a full-scale four-point bending test with extreme instrumentation and very sophisticated. But as I said at that time, now this has been repeated elsewhere. And what you can see on the deflection versus load is exactly the holy grail. You have deflection hardening behavior. That means that a steel fiber reinforced concrete lining can create a multi-cracking, which you can see in the photographs in the testing full scale. So, and then you have a photograph from the final lining, which is also, I have to say, from constructability point of view, was a full profile. So you have a continuous ring perfectly cast. In terms of, please one back. So, and this is the bottom line if you look at it from the CO2 point of view. You have a win for the employer and the contractor, saving 15,000 tons of steel. You have money, and you have reduction on embodied energy and embodied carbon by doing this solution. So I think this needs to be the present. The future, though, we can go even further. And we can really produce now strain hardening cementitious composites, which can be used as inner linings, either new construction or even repair. Thin linings that provide multi-cracking behavior, as you can see in a true uniaxial testing, if you see in the graph, where you have a high strain capacity. So we are not looking about the strength, but high strain capacity, a compatibility, strain compatibility you can achieve between primary and secondary lining. And that would enable a multi-cracking, but not compromise on durability or performance in that sense. So I think this is pretty much about materials, about technology, and about buy-in by all parties, contractor, designer, and also clients. That is an example.
Sotiris, Raj, please conclude on that, and we proceed to the next.
I think this is one of the challenges we are facing in the tunnel industry, how we can improve the sustainability without compromising durability. So as you know, our underground infrastructure, it has long tunnels, and every kilometer of tunnels consume a lot of volume of concrete. So my view is even durability itself is a sustainability principle. So if we can design the structure 100 years or 120 years or more, with a minimum interventions of the repair or repairing, then that structure itself is a sustainable structure. So rather than using low carbon or low carbon footprint material, then doing the repairing works every decade, then that's not the sustainable principle. So how we can improve the sustainability? So there are several pathways. As already Dr. Mahasi mentioned that we can use different cementitious materials, even so GGPS or fly ash and alternative materials to reduce the carbon footprint. Another important aspect is, as a designers, we normally inherit some conservatisms in our design. So we need to get rid of that conservatisms. I think the previous panels also discussed about these conservatisms. So how can we get that confidence to remove that conservatism? It is a questionable, but this will come with the experience and also from the past experience of lessons learned from other projects. So we have to utilize the other projects' lessons learned and mainly instrumentation monitoring and other things. I can tell you one example, what we did on HS2 in UK. So, as you know, twin tunnel, we have a certain space between the tunnel lining. So, we optimize the spacing. Then, when you come to the optimization of the spacing between the tunnel alignment, then you have a restricted space to put the shaft. Otherwise, you need to expand the tunnel lining at the shaft locations, then the alignment itself can cause, longer the length and increase the cross passage length and everything. So we went beyond our normal engineering, actually I would say. So we went into the, rather than traditional intersection of the TBM tunnel with the shafts, we went into the side-by intersection of the shaft. So this will allow us to reduce the shaft diameter. Then it will allow us to reduce the even diaphragm wall thickness, and even lot of temporary works we could have avoided. So this saves us a lot of carbon emissions. So we thought about it. We went to extra miles, but I appreciate here in Middle East the time is a very limited constraint in the design. So engineers can't think beyond their outer box.
Thank you,
so
Raj.
that information we need to bring.
Thank you very much. I would like to move on to that section of the panel discussion. I decided to go straight to something which makes more sense, not very, I would say, specialized, they're geotechnics, beam models in tunnel designs. And of course, these are the main questions which I raised to the panelists, but feel free to say something from your experience, including beam to the tunnels now, because we have used beam in other projects, but tunnels, I think it's now we're starting more and more. Dr. Ahmed?
When it comes to BIM, okay, yes, the BIM itself, it's not it's not a drafting tool or only clash detection tool. Okay, we have to utilize this all along the lifetime of the structure, even its tunnel or normal structure. For sure, contractors and consultants utilize the BIM in coordination and the clash detection, which is beneficial for them. It reduces the time, the clashes, increase the performance of an installation during construction. Okay. However, we have to look at this from the asset owner. Asset owner has to, we have to transfer this BIM models, okay, to the asset owner who will use it for maintenance work, to plan his maintenance work. But I believe, till now I haven't seen a full model or full comprehensive BIM through all stages of the project, from construction till the end of life of the structure or the tunnel or the project itself. Okay, so I think we need to work on this. Okay. For sure, by the help of consultants and contractors. Yeah.
Thank you very much, Dr. Ahmed. But Dr. Magazi and Sotiris, you have both of you the same interest because you are working for Blue Line now. Dr. Mohammed is a designer.
Correct.
And you are from the joint venture. You are looking very, very close to the issue of how the design can be successful. So please, Dr. Mohammed, what do you see about Blue Line now when you go to specifically for Blue Line? Are you using BIM in?
Yes, yes.
Please share with us your experience.
For me, because we have also some of our colleagues are in the audience here. They are more affected on this one. First of all, it is help for detection the clashes. Second, also assure that continuity of the infrastructure inside the tunnel, especially at the connection with the gallery, which is we are struggling to have a continuity of all the infrastructure inside the tunnel and connection with the gallery, with the interface with the walkway, with the interface with the cable, all of this requirement. I saw recently, I think Mr. Sotiris also is more involved. One of my colleagues is here, also Mr. Emra is more involving for this. And BIM help a lot to solve a lot of problems, help a lot to give a requirement for different discipline, what they need, their channel, their route inside the tunnel, because they get the model. I'm not a specialist. I'm trying to be very simple as I can. They extract the model and they provide it to them to help to assure that the proposed route, it is already implicated in the cross section. So as Dr. Ahmed said, it become a must. It just many years ago, it was just, I'm sorry to say, luxury, but now it become a must, and it must be, in my opinion, be good presented in the RFP of the project or the specification in a way to get the benefit of the BIM. It means it's not just we need a BIM to be there. No, we need a BIM to be there for 1, 2, 3, 4. This is just a quick comment. Yeah.
It's very good because that comes from your experience in that particular project now, which you are involved. And this is very important for all of us to understand that BIM will become the necessity for the next future projects.
Exactly.
Sotiris.
Yeah, I mean, you see on screen some early works which clearly demonstrate how much you could get out, especially with coordination and class detection and all of that. But I would like to raise a concern, and this comes from personal experience in all the projects that I have worked in tunneling. One of the key aspects of getting the program right is to start early the precasting. And early works, early design doesn't tie well with BIM development. So people should not underestimate how much work needs to build up the BIM libraries and all of that, and make people work in a coordinated manner. So yes, it's a great tool, but people need to understand that it takes time to. And it's very critical for projects that, especially in tunneling that involves precasting, that all these aspects are considered.
Thank you. Raj?
Yeah. So if you ask these questions 10 years ago, and when I start HS2 project in 2017, so it was used mainly for class detections. But nowadays, it's evolved significantly. I think now the greatest benefits we are getting through this BIM, the construction planning. So as you know, so underground success has multiple disciplines involved, as Dr. Masawi already mentions. So it has a MEP, structural engineers, geotechnical engineers, and everyone involved. They need to have certain space to put their assets. So if you want to allocate that space within the tunnel lining, we need to have a clear space proving exercise. So if you want to do that clear space proving exercise, we need to have a three-dimensional view. Then how we can construct those views. So that is very important. Even we are talking about optimizations and reducing the carbon footprint. So we need to allocate the space properly to optimize the tunnel diameter or anything. So the construction planning and the long-term thinking, even nowadays it's moving to the 4D. It's not the 3D, actually 4D. The contractors are benefiting heavily on this BIM model. They are simulating this construction sequence into the model, and they are seeing where they will have a problem. Even in the HS2, we have marked our geotechnical risk onto the BIM model. So when they go with the TAPAD, they can see where's the problem. So they're already alerted. So that's how the industry is benefiting now. Even we can think about it, this can be utilized for the long-term assets management purposes. Every data has a value. So if we collect more data, in the long-term asset management, if we give that 3D model to the asset owner, then they can fit all the instrumentations, monitoring, and that will be a very useful exercise to our industry.
Thank you very much, Raj. The last topic, because we're running out of time, I think it's important panel discussion. Everybody from ourselves wants to share experiences. But this is the last part. I had also something more to say, but I think it's better to conclude by expressing our views about smart monitoring in tunneling and the need of user-friendly solutions to assess the long-term structural health of tunnels linings. Dr. Ahmed.
Well, for sure, monitoring is important all along the lifetime, starting from construction till the end of the life of the project, okay, or of the tunnel itself. So, but I believe, yani, if it's more smarter, okay, it will help a lot. Yani, either during construction or during the lifetime of the structure. Because if it's smarter, so we will receive the monitoring data in real time. Maybe we'll have assistance of AI to analyze the data, give recommendation, and yani, reduce the workload on the asset owner and even or in the engineers during construction, during the project life. Okay, so to read all the manual reports and give comments by normal method. Okay. Also, it reduces the time of response or whenever the trigger is exceeded. So the time of response, instead of waiting for 1 week until we draw the graphs and take the readings. Okay, coordination between consultant and the engineer and owner. So the action plan here will be more faster than expected. So I believe it's very helpful to have this. This in terms of the structure settlement or deformation or vibration. But in terms of health, yes, I believe health monitoring is very, very important, considering the limited accessibility due to operational hours and restriction of engineering hours time. Okay, so it will help a lot if we have a health, if we continue for a health monitoring system to monitor the health of the structure.
Yes, please.
Still have time?
We have 10 minutes more and then we'll close. That's all. In
Okay.
10 minutes still.
Okay. Very quickly, I have to give a chance for my colleague. Yes, smart monitoring in the tunnel. I think it can have many aspects besides what Dr. Ahmed said. One of the issues a few minutes ago, we speak about durability. So if we can have also embedded strain gauges in the concrete, and it can measure the change of the strain and stresses along the time, it will be helpful also to assure that durability have been assured. One of the topics which are facing always that the intersection between tunnels. It means that when we have a tunnel for the metro, we have another tunnel for the infrastructure, whatever the purpose is, and always the debate and the discussion about the impact from one tunnel to another. I think the smart monitoring inside the tunnel can help this issue, especially when we have one tunnel will be constructed under the previous one. So generally, if we succeeded to have this kind of monitoring, permanent monitoring in the tunnel, have a lot of benefit for the owner and with the intersection with other tunnel, with other stakeholder. This is okay.
So Tiris.
Yeah, there's no doubt that there are, go to the next one because we don't have time. So there's no doubt that there is significant benefits for clients about long-term behavior and reliability of the structure. What I have is from, if you like, the contractor's point of view, benefits. 2 examples, they are both published. One has to do with measurements and mitigation of liabilities in an old tunnel. So the old existing tunnel is the big horseshoe tunnels that you see on the left, and the new tunnel is the one that goes deeper. So with having a simple fiber optic system installed, you could see and you trace the exact deformed shape of the old tunnel as a result of the new construction. So this now is a well-established technique and much more reliable, for example, for traditional methods. The other one, which actually I was involved from the point of view of the contractor, had to do with work that, again, has been published by Cambridge University, is about the SEL junction, which that had, it was basically a manifold. And we wanted to see how much really load transfer happens in this junction and how much this can be optimized. And to cut the long story short, yes, it can be optimized, and we see that the distribution of stresses, instead of extending 10 or more meters, was only within a 3-meter zone. So again, a very valuable lessons that had to do with legacy, basically knowledge transfer for future designs.
Thank you, Sotiris. Raj, you're...
Yeah, so the smart monitoring is an important aspect, should be part of our design. So what we are thinking, we are constructing the underground structures in a soil or rock material. It's very difficult to predict accurately. So the behavior of the ground can change. So the monitoring itself will give us a lot of information, our future generation, and also it will develop confidence on the designers. So this can be use all this valuable data for our future development, even theories or the design methodologies. So it will be a very useful exercise. I think every engineer should consider. The other thing is we can use this instrumentation monitoring for the long-term maintenance purpose. So rather than collecting data, we can set up some, nowadays is artificial intelligence and everything available. We can use this smart monitoring to minimize our maintenance or regular inspection details. So we can get this information to assess our structural performance. So definitely I will support this instrumentation monitoring and smart monitoring in the tunnel or underground infrastructure projects.
Thank you, Raj. So that is the end of our panel discussion. We would love to speak it more, but I think the time is limited now. Just to conclude, large sections versus small sections or ordinary ones, we think that the future is for large sections, but we have to be very careful as tunnel designers. BIM, very useful application, more and more often applicable now in tunnel designs for the reasons which all the panelists have raised. Smart monitoring for the structural health, monitoring of our final assets, very important. The tendency now for the clients is to prescribe, to provide specifications for these smart monitoring systems already implied in their assets. And of course, materials, different type of materials, different technologies can provide new ideas about how to lower the carbon footprint. Steel fibers, as you saw, polypropylene fibers maybe in the future. So by saying all this, I would like to thank all my colleagues participating in this panel, Dr. Ahmed Karib and Dr. Mohamed Magazi, Sotiris Psomas and Raj, all of them extremely experienced tunnel engineers. I hope you enjoyed that panel discussion. Please feel free to discuss with us during the breaks of the conference. Thank you very much indeed.